Right, hello and welcome back to another video. Today we are going to be focusing on a component that I've been wanting to use more, and I've got a rather large project planned around it, and that is a 7-segment display. We are going to be creating 3 circuits. The first one will just be basic counting up from 0 to 9. That will hopefully help familiarize us with the component, and the second one will be a countdown circuit of sorts that goes from 9 to 0. And then thirdly, we are going to make the display interactive by adding a button that lets us control what number is showing. So let's jump right into it and see how it goes. As you can see over here, we've got a 7-segment display, and I'm just going to explain to you what the different pins are because there are 10 pins. First of all, we've got A up here, which lights up the top of the segment, so it would be this bit. Then B, which upper right, and we've got a common. We've got C, which is lower right. We've got common. We've got D, which is the bottom. We've got E, which is lower left. F over here, which is upper left. And G, which is the central pin. The last one is DP, which is for the decimal point over here. All we're going to need for the first circuit is a breadboard, a couple of jumper wires, the 7-segment display, our Arduino, and the cable for the Arduino. And we are going to start off by plugging our 7-segment display in. Now we are going to connect our jumper wires from pin A through to pin G, and then also the decimal point. We're going to head over to the IDE and put in the code. Now let's upload it, and now we can continue. Now that we've got our code on our Arduino, we are going to plug the jumper wires into the relevant pins on our Arduino. So A connects up to pin 2, B 3, and it's going to go like that all the way to G being pin 8. The decimal point pin will go into pin 9, and the common cathode pin, which was one of the 2 in the center, is going to go to ground. Whoop, it's not the best wiring. Let's see if we can. Let's plug in our battery, and there you go. Nice and simple, 0 to 9. So circuit 1 is done. Now let's get into circuit 2. Here we've got the code for circuit 2. As you can see, it's a lot more than circuit 1, but it should be pretty fun to see it all come together and work. All of the wiring follows the same trend as it did for the first circuit. It's pretty nice that circuit 1 and 2 had the exact same physical build of the circuit. Really not too complicated, just following the circuit diagram. And the only thing that differed was the code. As you can see, we had nice flashing 0 at the end there, and that is also included in the code. Now what we are going to do is move on to circuit number 3. We have the code here for the third and final circuit. As you can see, there are quite a lot of cases here, and that is just so that the 7-segment display does the correct thing when we press the button. All of the pins from the 7-segment display still connect to the same place on our Arduino. The only difference now is that we have to include a push button, which we will connect up to terminal 10 on our Arduino, and to ground. We will also need a 10 kilo ohm pull down resistor, just like the last video. The pull down resistor will connect up to our 5 volt output on the Arduino. I'm not sure yet where the error is in the circuit, so right now we are just testing. This seems to be having the opposite effect, because it only stops when we press the button. So I'm not sure what's going on. I really don't get it. Now let's see. One of the pull down resistor is meant to go to 5 volts. Then the common cathode is meant to go to ground, and my phone died while I was busy filming and I didn't see. So I managed to get the circuit to work. I saw what the problem was. I saw another problem. Henry, please don't bark. I fixed it, and I don't think it captured any of that. But not only did my phone die, my SD card was also full, which is just great. So what I'm going to do now is I am going to show you what I did and what the circuit looks like now. Not much difference, but what I realized was the problem and the working circuits, because it didn't capture that. So what we've got over here is, come on battery, hold on. We've got our circuit. Can you see the number? If we click the button, it's upside down for you, I think. It was the right way around. I am very prepared, as I'm sure you can tell. Oh, gosh. Okay, so if we click the button, I'm not even holding it in. What's happening? That's one of the problems that I noticed was, yeah, if I held the button down for too long before releasing it, that it would jump a couple of numbers. And the problem with that was, in the code there's a delay of it's called delay to debounce button, and basically what that means is the number that was in those brackets was 200, so 200 milliseconds. And what that means is that every 200 milliseconds the number, according to the code, changed when the button was pushed down. So if you push the button down and released it very quickly, it would change numbers, no problem. If you held it down for too long, it would just run through the numbers, because from my understanding, the button doesn't really, let's move these out of the way. You see there, it's kind of, the button doesn't really tell the Arduino move the number 1 along. To me, it seems like the Arduino almost stores the next number, and as soon as the button's pressed, it completes the circuit inside the button, and then the next number displays, and it's just a matter of time, because I changed the number to 400 now, so 400 milliseconds, and so it'd be 400 milliseconds until then the next number is displayed, unless you stop that from happening by releasing the button. So that's one thing that if you do build the circuits, I would be aware of, that it's, if you just hold it down and let it run, it's on a timer, so it's just going to run through, which is no problem if you're wanting it to do that, but just something to be aware of. And then also just note that, okay, we've got the pull down resistor here, we've got the pull down resistor there. Once again, it's a 10k ohm resistor. Okay, with buttons, there's an internal circuit across the, because you've got a leg there and a leg there, and it's the same on the other side, and there's an internal circuit that runs through those legs. So if we've got another button here, so if we take a look at this, you can see from the back, this is what the front looks like without the top on. Okay, now you can see that there are 4 legs, right? And top one and bottom one in that column are internally connected, so they're never going to be disconnected. And it's the same for this side, that one and that one are internally connected. Now what happens when you push the button down is inside the, if you were to think of it as the left hand side and the right hand side, it's connected all through. It's connected. So we've got our pull down resistor, which is connected to our 5 volts, and the wire on the bottom side of it, which is internally connected, so that's always connected. The other side of it goes to ground, so just note that. And then our wire that goes to pin 10 on our Arduino is connected to the other column of legs, so when the button is pushed, then it's internally connected, and that lets the Arduino know that it number moves on. Hope that makes sense. I think I finally understand, hopefully, how these buttons work. I reckon I'm probably going to end up forgetting very soon, but yeah, I hope you enjoyed. Thanks for coming along for the adventure. Slightly more eventful than I'd hoped or planned for, but yeah, thank you very much, and I hope you have a fantastic day.